Alright, so here's my little project I've been working on. It's an Invocare electric wheelchair, and I converted it to be remote control. So as you can see, I took off the platform. There was a platform up here that had a linear actuator that could tilt the wheelchair seat forward, and then I put so I stripped that off, stripped all the chair stuff off, and these are the original batteries that came with it. They're pretty good. They're kind of like a gel cell. So I left those in. I got a Sabertooth 2x32 amp electronic speed controller. So I used the original harness to kind of hook that up. This is all temporary for now, just testing it. I have a little 2.4 gigahertz receiver for the transmitter. Not a bad little transmitter that I had. So I'm just kind of testing out, making sure it all works, and it is actually quite fast when I do it. But the big things were, I just wanted to test to make sure. I've read a lot about the braking system for these wheelchairs, and what's cool about this one is when you disengage the brake, on some wheelchairs the motor doesn't work then, but in this particular one you can engage the brake, so it's not gonna move on that side unless there's power applied to the brake. Then it releases it. But what's cool is I can disengage the brake, and I don't have to remove the brake from the wheelchair to get it to work, and it will move. So what's cool about this controller, the Sabertooth 2x32, is next to, it's got the USB input so you can program certain things into it, but next to the inputs from like the servo outputs from the receiver, there is two analog auxiliary inputs. I don't know exactly, I don't think you can program for different things, but then there's two outputs. So on this thing it's got that regenerative drive, and it has to shunt the power or something. I don't know, I was reading the instructions, I didn't really fully read all the way through them, but essentially when the motor's spinning down after power's been applied, it's got to put the power somewhere, and you can have it go out of those inputs to some big resistor banks if you want to use this with the power supply, or else it kind of pumps that energy back into the batteries. But what's cool with those outputs is you can program it to engage the electric brakes when the wheelchair stops moving, or when it stops receiving a signal, so you can retain and use the braking system in the whatever kind of robot you're doing right out of that controller. So kind of a cool thing. I don't think I'll need it, but I wanted to make sure I was going to test all this and kind of see that it works. So don't have to take out the brakes, which is really great, because I'm telling you, this wheelchair base, it's one of the heavy, this is like 1/4-inch steel. It's got these beefy motors on it, all kind of nicely wired up. It's got these big aluminum brackets, kind of hard to see behind all the plastic. I tried stripping a lot of this stuff off, but it's got these milled aluminum brackets. I don't know, it's got shocks. Each wheel is independent. It's kind of got a little bit of a suspension, and then it's got this back suspension, keep the thing, I don't know, stable. Pretty sweet. So yeah, my goal is just to get this thing up and running. I want to get all the electronics kind of sealed away. I want to make some metal plates to go over here, and I have a metal plate to go on top already, and just kind of seal the electronics in, and then we'll figure out what we want to do with it. I don't know, strap a chainsaw on it and make a battle bot or something. I don't know. But anyway, so that's the start to kind of my wheelchair, and I'll probably do more videos as time goes on. So we'll talk to you guys later.